Example 9 from chapter 4.2 says, the Federal Helium Reserve held about 32 billion cubic feet of helium in 2010 and is being depleted by about 2 billion cubic feet each year. Part A asks, give a linear equation for the remaining federal helium reserves R in terms of T, the number of years since 2010. And then part B says in 2020, what will the helium reserves be? And part C asks, if the rate doesn't change, in what year will the reserve be depleted? So, given the problem, we know that we begin with 32 billion. So this is going to be our y-intercept. And then it decreases by 2 billion each year. So we know that since it decreases, our slope is going to be negative. And since it's 2 billion per year, then our slope is negative 2. So our equation, r of t, is going to be linear. We have our slope times our variable and then our y-intercept. In this case, our values are already given. So rt equals negative 2 times t, and it's just 2 because it's in billions, and then plus 32, because we start with 32. So this is our answer for part A. Then for part B, it says, in 2020, what will the helium reserves be? So in the year 2020, it's been 10 years since 2010, because T is the years after 2010. So if we have T equals 10, then R of T equals negative 2 times 10 plus 32, and this comes out to be 12. So in the year 2020, there will only be 12 billion cubic feet left. And then part C asks, if the rate doesn't change, meaning it remains linear, in what year will the reserve be depleted? So we have to interpret what this means. For it to be depleted means that the reserves are just completely empty, so 0. Yeah. For what t is r of t 0? So if we set this equal to 0, 0 equals 32 minus 2t, then we have 2t equals 32, t equals 16. So 2010 plus 16 years means that in the year 2026, the reserves will be completely empty. So there's our answer.